I'd now like to look at a few sample problems and try to apply some of this. What do you think the name of this might be? You see an iron element, sulfur element. What's this 2,3 bit? That's reverse crisscross. This is iron. 3. How do I handle just a sulfur? Well, the rule is start saying sulfur but change it to "ide." This is iron 3 sulfide. What would you name this compound? Well, you don't know your polyatomic ions yet, but this is that immediate association you'll eventually make that is a sulfate. So you just say sulfate. Whenever you see the polyatomic ion, just say it. Now a sulfate, you will memorize, is a 2- polyatomic. That means this must be Fe2+ because it's going 1-to-1 with the sulfate. So this is iron 2 sulfate. Let's name this. Here's iron. Do you know the name of this polyatomic ion yet? It's a little early for you to know that. But reverse crisscross, there's an understood 1 here. It's a -1. This is a 3+. Iron 3. Have you figured it out? Perchlorate. It's got the 4 oxygens on it. It's the perchlorate. How about PbCO3? Again, polyatomic ion is what you should be saying to yourself. Carbonate has a 2- charge, so this must be lead 2 carbonate. I have 2 worksheets that you'll work on, and drill and practice is the way to learn these. We've now finished our discussion of ionic compounds, and now we're going to move into molecular compounds, which, as a reminder, are when 2 or more nonmetals bond with each other. And the protocol for naming these types of compounds is to use a Greek prefix, which we must memorize. We say Greek prefix, name a first element, Greek prefix, name a second element, and change the ending to IDE. The Greek prefixes are mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. And some examples are CO2, which you've known for a long time is carbon dioxide. That di is a Greek prefix. We don't say mono typically on the first atom because it's cumbersome. Carbon dioxide. We do say mono with the second atom, as in this compound, which is laughing gas. We say di-nitrogen monoxide. And we don't put 2 O's next to each other, we just drop 1. Dinitrogen monoxide. This compound I put here so you don't get led astray and think that a polyatomic ion is a molecular compound. You memorize it as nitrate. This next compound is S2O3, no charges. It is a molecular compound. It's 2 nonmetals bonded, so it's disulfur trioxide. Next up, PO4, 2 nonmetals, phosphorus, dropping the mono, tetraoxide. And lastly, you say, you will not catch me. I know that's phosphate. I know my polyatomic ions. Hopefully you're saying to yourself, molecular compounds are a whole lot easier to name than ionic compounds, and you're right. We're now going to practice naming acids. An acid is a compound that gives away an H+ in water. There are 2 basic kinds of acids. There are binary acids, which is just the hydrogen with 1 other element, or there are the oxy acids, which, as the name implies, have some oxygens present. To name a binary acid, you say hydro, the name of the nonmetal, and change it to ic at the end, and then you say the word acid. For example, here are some common strong acids. Hydrochloric acid, hydrobromic acid, hydroiodic acid, hydrosulfuric acid. Note I put 2 hydrogens with this sulfur. That's because sulfide comes in with a 2- charge, so I need 2 H's to balance it out. The halogens, chloride, bromide, iodide, are a -1, so it's a 1-to-1 with the hydrogen. The oxy acids are based on polyatomic ions that you've memorized. It makes it a lot easier for you to know these. Nitric acid is based on nitrate. Sulfurous acid is based on sulfite. Sulfuric acid is based on sulfate. Phosphoric acid is based on phosphate. Note, phosphate has a 3- charge, so I need 3 hydrogens to go with it. Sulfate has a 2- charge, so I need 2 hydrogens to go with it. I now want to mix it up and do an overall nomenclature slide where it could be one of any type. So let's practice. How about CO? What would you call that? You say 2 nonmetals. I will go to the Greek prefix method. I don't say mono on the first one, but I do say mono on the second one. That's carbon monoxide. Next up, you say, here's a metal with a nonmetal. I will go to the ionic scheme, and I'll say calcium. I don't say difluoride. That is not the scheme for ionic compounds. I also don't use a Roman numeral because this is a column 2 metal and the charge is certain. I just say calcium fluoride. Next up is HF. You see an H in the front, you immediately say, oh, that's an acid. Binary acids, hydrofluoric acid. FeNO33, you say polyatomic ion, metal. This is an ionic compound. It's also a transition metal. I have to use my Roman numerals. Well, nitrate I memorized was -1, so I have 3 nitrates. Therefore, this is iron 3 nitrate. Iron 3 plus went with those nitrates to require 3 to balance it. Next up, you say, acid. This is the perchlorate polyatomic ion. So this is perchloric acid. And lastly, you see this is sulfite polyatomic ion turned into an acid with 2 hydrogens. We name it sulfurous acid. There are other familiar oxy acids that you can see on table 5.7 in your book. And here is our summary of all the different naming schemes that we have learned in this chapter. Ionic compounds are challenging in that you have to do the crisscross and know the charges, and you also have to memorize all those polyatomic ions. Molecular compounds, you go to the Greek prefixes and basically just say the elements' names, so they're pretty easy. And then the acids, you have 2 basic kinds. The binary acids, you say hydro, something ic acid, and then the oxy acids are based on the polyatomic ion's name. There's one final thing that we need to cover in this chapter, and that is how to calculate the mass of a compound. It's really very easy. We add up all the atoms' masses. So as shown here, the formula mass, I usually say molar mass, even though we haven't defined what a mole is yet. The formula mass is the number of atoms of a particular element times the atomic mass of that element, plus the second one, plus the third one, etc., etc. For instance, let's figure out these compound masses. You need to have a periodic table handy, and I'll tell you in advance that I always just work in whole numbers to keep it simple. If you look at the periodic table, the molar mass of carbon is 12, and the molar mass of oxygen is 16. 1-to-1, sum it up, it's 28 grams, and it's called per mole. Next up is calcium with 2 fluorines. Calcium has a molar mass of 40, and fluorine has a mass of 19, so that's 40 plus 38, so it's 78. Next up is hydrogen, which is worth 1, and fluorine, which is worth 19, so that's 20, and it's grams per mole. Next we have iron, which has a mass of basically 59. I'm rounding it. And now we get some good practice with parentheses. You have to multiply everything in here by 3. A lot of times what I do is I figure out what's on the inside, and then I'll multiply that sum by 3. So I'm going to say 3 times 14 plus 48. So that's 62 in here, and 62 times 3 would be 6, and 18, so it's 186 plus 59. It'd be 245 grams per mole. Next you have 1 for hydrogen. Chlorine is worth 35.5. This is one time I actually used the decimal. And 4 oxygens are 4 times 16, which is 64. So when you do this, it's 65 plus 35.5, and you'll get 0.5, carry the 10, it's 100.5 grams per mole. Lastly, you've got 2 hydrogens, they're worth 1 each, 2 times 1, plus sulfur's worth 32, plus 3 oxygens are 3 times 16, which is 48. So what does that sum to? 32 plus 48 would be 80. Plus 2, it's 82 grams per mole. I usually call this the molar masses, but we haven't defined the mole yet. It's a common unit in chemistry. Just to review some of the ideas that we've talked about in this chapter revolved around compounds, and that the great diversity in nature attests to the fact that these atoms are combining and making an infinite variety of compounds. They have specific ratios in which the atoms combine, and these are written as formulas which tell us the whole number multiples of the atoms in the compound. We go through a nomenclature protocol. We split it out by the types of bonds the atoms have with each other, whether they're ionic, metallic, covalent, or acids. And finally, to find the mass of a compound, you just add up the masses of all of the atoms. Practice your polyatomic ions, memorize those, practice using the tools on the website. We get good at naming compounds and writing formulas by doing it over and over again until it becomes a habit to us and we can flow with the protocols. Thanks for your attention.